Drill bits are cutting tools used to remove material to create holes, almost always of circular cross-section. Drill bits come in many sizes and shape and can create different kinds of holes in many different materials. In order to create holes, drill bits are attached to a drill, which powers them to cut through the workpiece, typically by rotation. The drill will grasp the upper end of a bit called the shank in the chuck. Drill bits come in standard sizes, described in the Drill Bit Sizes article. A comprehensive drill bit and tap size chart lists metric and imperial sized drill bits alongside the required screw tap sizes. There are also certain specialized drill bits that can create holes with a non-circular cross-section. While the term drill may refer to either a drilling machine or a drill bit for use in a drilling machine, in this article, for clarity, drill bit a bit is used throughout to refer to a bit for use in a drilling machine, and drill refers always to a drilling machine. Characteristics. Drill bit geometry has several characteristics. The spiral in the drill bit controls the rate of chip removal. A fast spiral drill bit is used in high feed rate applications under low spindle speeds, where removal of a large volume of chips is required. Low spiral drill bits are used in cutting applications where high cutting speeds are traditionally used, and where the material has a tendency to gall on the bit or otherwise clog the hole, such as aluminum or copper. The point angle, or the angle formed at the tip of the bit, is determined by the material the bit will be operating in. Harder materials require a larger point angle, and softer materials require a sharper angle. The correct point angle for the hardness of the material influences wandering, chatter, hole shape, and wear rate. The lip angle determines the amount of support provided to the cutting edge. A greater lip angle will cause the bit to cut more aggressively under the same amount of point pressure as a bit with a smaller lip angle. Both conditions can cause binding, wear, and eventual catastrophic failure of the tool. The proper amount of lip clearance is determined by the point angle. A very acute point angle has more web surface area presented to the work at any one time, requiring an aggressive lip angle, where a flat bit is extremely sensitive to small changes in lip angle due to the small surface area supporting the cutting edges. The length of a bit determines how deep a hole can be drilled, and also determines the stiffness of the bit and accuracy of the resultant hole. While longer bits can drill deeper holes, they are more flexible, meaning that the holes they drill may have an inaccurate location or wander from the intended axis. Twist drill bits are available in standard lengths, referred to as stub length or screw machine length, the extremely common jobber length, and taper length or long series. Most drill bits for consumer use have straight shanks. For heavy-duty drilling in industry, bits with tapered shanks are sometimes used. Other types shanks used include hex-shaped, and various proprietary quick-release systems. The diameter-to-length ratio of the drill bit is usually between 1:1 and 1:10. Much higher ratios are possible, but the higher the ratio, the greater the technical challenge of producing good work. The best geometry to use depends upon the properties of the material being drilled. The following table lists geometries recommended for some commonly drilled materials. Many different materials are used for or on drill bits depending on the required application. Many hard materials, such as carbides, are much more brittle than steel, and are far more subject to breaking, particularly if the drill is not held at a very constant angle to the workpiece, e.g., when handheld. Steel's soft low-carbon steel bits are inexpensive, but do not hold an edge well and require frequent sharpening. They are used only for drilling wood. Even working with hardwoods rather than softwoods can noticeably shorten the lifespan. Bits made from high-carbon steel are more durable than low-carbon steel bits due to the properties conferred by hardening and tempering the material. If they are overheated, they lose the temper, resulting in a soft cutting edge. These bits can be used on wood or metal. High-speed steel is a form of tool steel. HSS bits are hard and much more resistant to heat than high-carbon steel. They can be used to drill metal, hardwood, and most other materials at greater cutting speeds than carbon steel bits, and have largely replaced carbon steels. Cobalt steel alloys are variations on high-speed steel that contain more cobalt. They hold their hardness at much high temperatures and are used to drill stainless steel and other hard materials. The main disadvantage of cobalt steels is that they are more brittle than standard HSS. Others, tungsten carbide and other carbides, are extremely hard and can drill virtually all materials, while holding an edge longer than other bits. The material is expensive and much more brittle than steels. Consequently, they are mainly used for drill bit tips. Small pieces of hard material fixed or brazed onto the tip of a bit made of less hard metal. However, it is becoming common in job shops to use solid carbide bits. In very small sizes it is difficult to fit carbide tips in some industries, most notably PCB manufacturing, requiring many holes with diameters less than 1 mm. Solid carbide bits are used. Polycrystalline diamond is among the hardest of all tool materials and is therefore extremely resistant to wear. It consists of a layer of diamond particles, typically about 0.5 mm thick, bonded as a sintered mass to a tungsten carbide support. Bits are fabricated using this material by either brazing small segments to the tip of the tool to form the cutting edges or by sintering PCD into a vein in the tungsten carbide nib. The nib can later be brazed to a carbide shaft. It can then be ground to complex geometries that would otherwise cause braze failure in the smaller segments. PCD bits are typically used in the automotive, aerospace, and other industries to drill a brace of aluminum alloys, carbon fiber reinforced plastics, and other abrasive materials, and in applications where machine downtime to replace a sharp and worn bits is exceptionally costly. It should be noted that PCD is not used on ferrous metals due to excess wear resulting from a reaction between the carbon in the PCD and the iron in the metal. Coatings. Black oxide is an inexpensive black coating. A black oxide coating provides heat resistance and lubricity, as well as corrosion resistance. Coating increases the life of high-speed steel bits. Titanium nitride is a very hard ceramic material that can be used to coat a high-speed steel bit, extending the cutting life by 3 or more times. Even after sharpening, the leading edge of coating still provides improved cutting and lifetime. Titanium aluminum nitride is a similar coating that can extend tool life 5 or more times. Titanium carbon nitride is another coating also superior to titanium 3 nitride. Diamond powder is used as an abrasive most often for cutting tile, stone, and other very hard materials. Large amounts of heat are generated by friction, and diamond-coated bits often have to be water-cooled to prevent damage to the bit of the workpiece. Zirconium nitride has been used as a drill bit coating for some tools under the Craftsman brand name. Universal bits. General-purpose drill bits can be used in wood, metal, plastic, and most other materials. Twist drill bits. The twist drill bit is the type produced in largest quantity today. It comprises a cutting point at the tip of a cylindrical shaft with helical flutes. The flutes act as an Archimedean screw and lift swarf out of the hole. The twist drill bit was invented by Stephen A. Morse of East Bridgewater, Massachusetts in 1861. The original method of manufacture was to cut 2 grooves in opposite sides of a round bar, then to twist the bat to produce the helical flutes. Nowadays, the drill bit is usually made by rotating the bar while moving it past a grinding wheel to cut the flutes in the same manner as cutting helical gears. Twist drill bits range in diameter from 0.002 to 3.5 in and can be as long as 25.5 in. The geometry and sharpening of the cutting edges is crucial to the performance of the bit. Small bits that become blunt are often discarded because sharpening them correctly is difficult and they are cheap to replace. For larger bits, special grinding jigs are available. A special tool grinder is available for sharpening or reshaping cutting surfaces on twist drill bits in order to optimize the bit for a particular material. Manufacturers can produce special versions of the twist drill bit varying the geometry and the materials used to suit particular machinery and particular materials to be cut. Twist drill bits are available in the widest choice of tooling materials. However, even for industrial uses, most holes are drilled with standard high-speed steel bits. The most common twist drill bit has a point angle of 118 degrees, acceptable for use in wood, metal, plastic, and most other materials, although it does not perform as well as using the optimum angle for each material. In most materials it does not tend to wander a dig in. A more aggressive angle, such as 90 degrees, is suited for very soft plastics and other materials. It would wear rapidly in hard materials. Such a bit is generally self-starting and can cut very quickly. A shallower angle, such as 150 degrees, is suited for drilling steels and other tougher materials. This style of bit requires a starter hole, but does not bind or suffer premature wear so long as a suitable feed rate is used. Drill bits with no point angle are used in situations where a blind, flat-bottomed hole is required. These bits are very sensitive to changes in lip angle, and even a slight change can result in an inappropriately fast cutting drill bit that will suffer premature wear. Long series drill bits are unusually long twist drill bits. However, they are not the best tool for routinely drilling deep holes, as they require frequent withdrawal to clear the flutes of swarf and to prevent breakage of the bit. Instead, gun drill bits are preferred for deep hole drilling. Step drill bits. A step drill bit is a drill bit that has the tip ground down to a different diameter. The transition between this ground diameter and the original diameter is either straight to form a counterbore, or angled to form a countersink. The advantage to this style is that both diameters have the same flute characteristics, which keeps the bit from clogging when drilling in softer materials, such as aluminum. In contrast, a drill bit with a slip-on collar does not have the same benefit. Most of these bits are custom-made for each application, which makes them more expensive. Unibit. A unibit is a roughly conical bit with a stair-step profile. Due to its design, a single bit can be used for drilling a wide range of hole sizes. Some bits come to a point and thus self-starting. The larger size bits have blunt tips and are used for hole enlarging. Unibits are commonly used on sheet metal and in general construction. One drill bit can drill the entire range of holes necessarily on a countertop, speeding up installation of fixtures. They are most commonly used on softer materials, such as plywood, particle board, drywall, acrylic, and laminate. They can be used on very thin sheet metal, but metals tend to cause premature bit wear and dulling. Unibits are ideal for use in electrical work where thin steel, aluminum, or plastic boxes and chassis are encountered. The short length of the unibit and ability to vary the diameter of the finished hole is an advantage in chassis or front panel work. The finished hole can often be made quite smooth and burr-free, especially in plastic. An additional use of unibits is deburring holes left by other bits, as the sharp increase to the next step size allows the cutting edge to scrape burrs off the entry surface of the workpiece. However, the straight flute is poor at chip ejection, and can cause a burr to be formed on the exit side of the hole, more so than a spiral twist drill bit turning at high speed. The Unibit was invented by Harry C. Oakes and patented in 1973. It was sold only by the Unibit Corporation in the 1980s until the patent expired, and was later sold by other companies. Unibit is a trademark of Owen Industrial Tools. Hole saws take the form of a short open cylinder with saw teeth on the open edge, used for making relatively large holes in thin material. They remove material only from the edge of the hole, cutting out an intact disc of material. Unlike many drills which remove all material in the interior of the hole, they can be used to make large holes in wood, sheet metal and other materials. Metal drill bits. Center and spotting drill bits. Center drill bits, occasionally known as slocum drill bits, are used in metalworking to provide a starting hole for a larger size drill bit to make a conical indentation in the end of a workpiece in which to mount a lathe center. In either use the name seems appropriate, as the bit is either establishing the center of a hole or making a conical hole for a lathe center. However, the true purpose of a center drill bit is the latter task, while the former task is best done with a spotting drill bit. Nevertheless, because of the frequent lumping together of both the terminology and the tool use, suppliers may call center drill bits combined drill and countersinks in order to make it unambiguously clear what product is being ordered. They are numbered from 00 to 10. Use in making holes for lathe centers. Center drill bits are meant to create a conical hole for between centers manufacturing processes. That is, they provide a location for a center to locate the part about an axis. A workpiece machined between centers can be safely removed from one process and set up in a later process with a negligible loss in the coaxiality of features. Antier and LT 0.0001 in is held in cylindrical grinding operations, as long as conditions are correct. Use in spotting hole centers. Traditional twist drill bits may tend to wander when started on an unprepared surface. Once a bit wanders off course, it is difficult to bring it back on center. A center drill bit frequently provides a reasonable starting point, as it is short and therefore has a reduced tendency to wander when drilling is started. While the above is a common use of center drill bits, it is a technically incorrect practice and should not be considered for production use. The correct tool to start a traditionally drilled hole twist drill bit is a spotting drill bit. The included angle of the spotting drill bit should be the same as, or greater than, the conventional drill bit, so that the drill bit will then start without undue stress on the bit's corners, which would cause premature failure of the bit and a loss of hole quality. Most modern solid carbide bits should not be used in conjunction with a spot drill bit or a center drill bit, as solid carbide bits are specifically designed to start their own hole. Usually, spot drilling will cause premature failure of the solid carbide bit and a certain loss of hole quality. If it is deemed necessary to chamfer a hole with a spot of center drill bit when a solid carbide drill bit is used, it is best practice to do so after the hole is drilled. When drilling with a handheld drill, the flexibility of the bit is not the primary source of inaccuracy, it is the user's hands. Therefore, for such operations, a center punch is often used to spot the hole center prior to drilling a pilot hole. Core drill bit. The term core drill bit is used for two quite different tools. Enlarging holes. A bit used to enlarge an existing hole is called a core drill bit. The existing hole may be the result of a core from a casting or a stamped hole. The name comes from its first use, for drilling out the hole left by a foundry core, a cylinder placed in a mold for a casting that leaves an irregular hole in the product. This core drill bit is solid. These core drill bits are similar in appearance to reamers, as they have no cutting point, a means of starting a hole. They have 3 or 4 flutes which enhances the finish of the hole and ensures the bit cuts evenly. Core drill bits differ from reamers in the amount of material they are intended to remove. A reamer is only intended to enlarge a hole a slight amount, which, depending on the reamer's size, may be anything from 0.1 mm to perhaps a millimeter. A core drill bit may be used to double the size of a hole, using an ordinary 2-flute twist drill bit to enlarge the hole resulting from a casting core will not produce a clean result. The result will possibly be out of round, off-center, and generally of poor finish. The 2-fluted drill bit also has a tendency to grab on any protuberance which may occur in the product, extracting core a hollow cylindrical bit which will cut a hole with an annular cross-section and leave the inner cylinder of material intact. Often removing it is also called a core drill bit or annular cutter. Unlike other drills, the purpose is often to retrieve the core rather than simply to make a hole. A diamond core drill bit is intended to cut an annular hole in the workpiece. Large bits of similar shape are used for geological work, where a deep hole is drilled in sediment or ice and the drill bit, which now contains an intact core of the material drilled with a diameter of several centimeters, is retrieved to allow study of the strata. Countersink bit. A countersink is a conical hole cut into a manufactured object. A countersink bit is the cutter used to cut such a hole. A common use is to allow the head of a bolt or screw, with a shape exactly matching the countersunk hole, to sit flush with or below the surface of the surrounding material. A countersink may also be used to remove the burr left from a drilling or tapping operation. Ejector drill bit, used almost exclusively for deep hole drilling of medium to large diameter holes. An ejector drill bit uses a specially designed carbide cutter at the point. The bit body is essentially a tube within a tube. Flushing water travels down between the two tubes. Chip removal is back through the center of the bit. Gun drill bit. Gun drills are straight fluted drills which allow cutting fluid to be injected through the drill's hollow body to the cutting face. Indexable drill bit. Indexable drill bits are primarily used in CNC and other high-precision production equipment, and are the most expensive type of drill bit, costing the most per diameter and length. Like indexable lathe tools and milling cutters, they use replaceable carbide ceramic inserts as a cutting face to alleviate the need for a tool grinder. One insert is responsible for the outer radius of the cut, and another insert is responsible for the inner radius. The tool itself handles the point deformity, as it is a low-wear task. The bit is hardened and coated against wear far more than the average drill bit, as the shank is non-consumable. Almost all indexable drill bits have multiple coolant channels for prolonged tool life under heavy usage. They are also readily available in odd configurations, such as straight flute, fast spiral, multi-flute, and a variety of cutting face geometries. Typically, indexable drill bits are used in holes that are no deeper than about 5 times the bit diameter. They are capable of quite high axial loads and cut very fast. Left-hand bit. Left-hand bits are almost always twist bits and are predominantly used in the repetition engineering industry on screw machines or drilling heads. Left-handed drill bits allow a machining operation to continue where either the spindle cannot be reversed or the design of the machine makes it more efficient to run left-handed. With the increased use of the more versatile CNC machines, the use is less common than when specialized machines were required for machining tasks. Screw extractors are essentially left-hand bits of specialized shape, used to remove common right-hand screws whose heads are broken or too damaged to allow a screwdriver tip to engage, making use of a screwdriver impossible. The extractor is pressed against the damaged head and rotated rotated counterclockwise and will tend to jam in the damaged head and then turn the screw counterclockwise, unscrewing it. For screws that break off deeper in the hole, an extractor set will often include left-handed drill bits of the appropriate diameters so that grab holes can be drilled into the screws in a left-handed direction, preventing further tightening of the broken piece. Metal spade bit. A spade drill bit for metal is a two-part bit with a tool holder and an insertable tip, called an insert. The inserts come in various sizes that range from 7/16 to 2.5 inches. The tool holder usually has a coolant passage running through it. They are capable of cutting to a depth of about 10 times the bit diameter. This type of drill bit can also be used to make stepped holes. Straight fluted bits. Straight fluted drill bits do not have a helical twist like twist drill bits do. They are used when drilling copper or brass because they have less of a tendency to dig in or grab the material. Trepanate. Trepan, sometimes called a BTA drill bit, is a drill bit that cuts an annulus and leaves a center core. Trepans usually have multiple carbide inserts and rely on water to cool the cutting tips and to flush chips out of the hole. Trepans are often used to cut large diameters and deep holes. Typical bit diameters are 6 to 14 in and hole depth from 12 in up to 71 feet.